Good morning, good afternoon, good evening from whichever location you are watching this video. A very warm welcome to QuestPond's YouTube channel. And what are we doing today, right? So before we tell what are we doing today, so today is 10th of July and 10th of July is a Guru Purnima day. So first thing, a very happy Guru Purnima to everyone. So what are we doing in this video? In this video, we're going to go and learn microservices step by step, lesson by lesson, chapter by chapter. I am flashing all the chapters. Approximately this will be a 1 hour of video, I guess, right? Because this clip I'm recording on the start, right? But I guess that it should be approximately 1+ hours of video, and it should have approximately 16 to 17 chapters. So all of those chapters I'm flashing on the screen out there. So let us go ahead and start these lessons, right? And before we start these lessons, I want to just announce a super duper gift to everyone. So if you go and if you share this video on LinkedIn and if you tag me on LinkedIn, so when you share this video, if you tag me on LinkedIn, right, I will give you a wonderful gift, which is the architecture interview question PDF. So if you're going for architect interviews out there, you will get this wonderful gift, which is flashed on the screen. Only thing is that when you share this video, right, on your LinkedIn, please make sure that you send us a mail at questpond@questpond.com. Now, definitely, there is a complete series of microservices which we'll be launching internally. Remember that internally in QuestPond, we have a lot of training programs which happen. So one is we have the recorded videos, another one we have the training program as well. So we are also having the microservices training program. I would suggest that you should go to questpond.com and you should chat on the chat window out there, to see that when is the microservices training and what kind of videos we have, right? So that is one part. Second, guys, I want to give part 2 also free. Now this is lesson 1, right? 18 chapters, 17, 18 chapters, whatever it is, right? I also want to give part 2, right? Lesson 2 as well. But I want to see that developers are really interested. It is not that I just want to give it out free and nobody is interested, right? So if you hit 2000 likes on this video, I will release the second chapter, the second lesson on YouTube, right? Remember, we have Teachers Day, which is coming up after 1 or 2 months. I don't know the exact date, right? So if you can hit 2000 likes out there, must be I can give the video 2 of microservices also free on this channel. Now, before we start these 16, 17 chapters, whatever I'm flashing on the screen, I want to talk about, talk about specifically this 1 hour, the nature of this 1 hour of training. The nature of this lessons, this complete lesson of 1 hour is pure theory. Why? Because whenever we are starting with microservices, right, one is the technical part. Yes, we have to create the classes, we have to do CQRS, we have to do entity, value, objects, all that, right? But before that, there is a very important thing in microservices, and that is the planning part. That is the strategy part. And many developers miss that. So I know that this lesson for people who are like very much hyper hands-on, right? For them, it will be like, oh, these are just talks, right? No, it is not just talks. Remember that most of my trainings are hands-on. But I felt that this time, at least if I'm starting with microservices, first I should clarify the different vocabularies of microservices. Domain, subdomain, bounded context, context map, all that different terminologies. If they are not clear, right, your microservices base does not start. So this is going to be a 1 hour of theory lesson, but I would suggest everyone to go and watch it. I know that it's going to be boring. So what you can do is that this is just a suggestion from me. What you can do is that you can go ahead and let us say that you watched today 10 minutes. So you can watch for 10 minutes and then down below you can just tag saying that I watched for 10 minutes. I will come back tomorrow, and from tomorrow again watch, right? Because if this theory is clear, if all these vocabularies, bounded context, context map pattern, upstream, downstream, I'm just looking at my subdomain, core domain, strategic DDD, tactical DDD, right? If this is clear, right, then your journey of microservices is smooth. See, because technically everybody knows, right, how to create classes, how to do aggregation, composition. So that is not a big part over there. We can easily manage it, right? That is also tough part. But I feel that this is the important part. And if this part is not right, your choice about microservices also will not be right. Many people say, right, when should we use microservices? Why should we use microservices? if you're going through this approach, right, this DDD approach, right, then you will come to know that should I do microservices also or not, right? So these theory lessons are very important, right? So with that, let us get started with chapter 1. Because this is a microservices lesson, chapter 1, we will focus on the definition of microservices. So let's get started with chapter 1, the definition of microservices. Microservice is an architecture design approach wherein we build application in a independent, self-contained, deployable service. This is the first point. It should be independent. It should be a self-contained project having its own database. We can deploy that separately, right? So it should be a self-contained deployable service. First point. Second point, each one of these services should represent a business functionality. This is the second thing. And third important thing is that these services should communicate with each other in a loosely coupled way, either by using queues or either by using API, or there should be some kind of a database in between, but the communication should happen in a loosely coupled way, right? So 3 points. Microservice, it is an architecture design approach wherein we create independent, self-contained, deployable service, and each one of these services represents a business functionality, and these services talk with each other through a technically loosely coupled infrastructure like a queue, or must be an API, or must be a database, or must be something else. So let us go ahead and try to understand this with an example. So whatever 3 points we have discussed, let us try to understand with an example. So you can see, I'm just taking an example of an HIMS system, an hospital management system, right, or an EMR, right? So if you look at a hospital management system, you can have different functionalities like you can have an online appointment, you can have a billing, you can have an inventory functionality, you will have a pharmacy functionality, you can have accounting functionality, you can have a clinical functionality, and so on, right? So these are self-contained business functionality, right? So what you do in a microservice is that you take each one of these functionalities and you create a separate service. You create a separate service, right? So each one of these functionality will have its own code base, right? They will have its own database, right? It is like, a self-contained application by itself, right? And these services, like example, you have a billing out here, it has its own database, you have an accounting out here, you have its own database. Now let us say that you say, okay, in billing, if somebody goes and puts some data out there, and he says that, okay, this is the money, and you want to make an entry into accounting, then that will happen via a queue, right? Now it can be a queue. So these services actually communicate via some queue. So in a billing, when you make an entry, that will come in the queue out here, right? And then that will be pulled up by the accounting system. It can be a push, it can be a pull, right? Whatever it is, right? And it will make an entry into the accounting system, right? So microservice, as we said, it is nothing but where you break your application into small business functionalities, and each of these business functionalities represent a service, right? And these services actually communicate via a queue, or must be via an API call, or sometimes people also can make a database. They can have a database out here saying that, okay, let's make entry into the database and let that application read from a database, right? So whatever way you choose to communicate between the service, please make sure that this should be loosely coupled, right? So that's an example of how to visualize a microservice architecture. For example, for a hospital system, in the same way for ERP also you have different functionalities like inventory and payroll and so on, accounting, right? So that's one example. Now one more architecture which is actually opposite to microservice, or we can say it is contrary to microservice, is termed as monolith, right? So what happens in microservice, right? In microservice we have separate service, right? Separate code base. Developers develop them separately, they build them separately, they deploy them separately, right? But in case of monolith, which is actually a classical one, you have just one single code base for everyone. So definitely the application is modular. So internally you will have classes, internally you will have all that thing modular, you will have the model view controller, you will have a data access layer, or must be a repository, you will have separate components for technical things, caching, logging. That internally, that logical modularity is there, but there is only single code base, right? Internally, everything is modular and must be there is single database. You can have multiple databases, but I'm just saying, but mostly it will be single database. You can have multiple database. For example, some of the developers can have database which is for logging audit trail, right? So that kind of database can be there multiple, but storing the business functionality probably will be in one database. And the deployment, the most important sign that it is monolith is that the whole deployment happens in one go, right? It is not independent. Here, there are independent deployments, please understand, right? So in monolith architecture, right, what happens is you have a single code base, you have a single database, and everybody works on that single code base, right? In case of microservices, they are independent. Developer teams are independent with each other. Definitely, they, when it comes to the team communication, the queues communication, the team will sit together, but most of the time, they are developing independently, they are deploying independently. One does not have effect on the other, right? So the other technical architecture, which we have all been following, is monolith. So now let us try to understand that what is the benefit of microservices. Now, if you go to any developer out there, right, every developer has a view, how they think that they can get benefited from microservices. Someone would say parallel development, somebody will say individual deployment, individual scalability, technical flexibility, fault are isolated because the services are deployed separately. Someone thinks about CI/CD, someone thinks about team autonomy, that team are individual and parallel, right? High reusability and whatnot, right? So everybody has its own way of looking at microservices, and they think about the way they look at benefits, right? It can vary from developer to developer, right? I would put my perspective out here. See, whenever any technical architecture is decided, right, one of the biggest reason for deciding the technical architecture should be business driven. I again repeat this, it should be business driven, it should be organizational driven. And I think, for microservices, the biggest business driven or organizational driven benefit is team autonomy. So you can see on my screen, so this is microservice. So microservice, I think, first, the decision to use microservice should be organizational driven, should be business driven. And from my perspective, see, please note, I'm talking about my perspective, right? I feel that it is team autonomy. Please let me know down in the comments below what you think is your one biggest decision that why you will choose microservice. Don't give me 10 decisions, because if you give me 10 decisions, then again it becomes too mundane, right? So just write down in the comments below what is your biggest decision that you think that you will choose microservice. I feel it is team autonomy. What do you mean by team autonomy? Team autonomy means that every service the team will own, build, deploy, maintain independently. So team autonomy means that the team will own, build, deploy, maintain independently. That's what is termed as team autonomy. And with that, what happens? Think about it. So if every individual team is just working on their services, right, then one team does not have to sit in other teams' meeting. For example, whenever you are having a regular stand-up meeting, so you are working on accounting, and because it is a monolith application, the inventory person also has to come and sit, because if something happens in accounting, some tables change in accounting, it will affect the inventory developer also, right? So what happens is they have to sit in each other's meeting, even though it is not so fruitful, but because there can be impact of their changes, right, they have to sit, right? So if you're doing parallel development, then you don't have to really sit in each other's meeting. And the second thing which I feel out here is, right, and please correct me, is that when you are having individual team, what you can do is that if let us say you have a simple screens to be made, right? Let's say example, you have billing, and let's say you have accounting. Now you know that accounting is very complex. Over there, you need a person who understands accounting, who understands debit, who understands credit, journals and all that. So you need a person to be a little bit smarter. He has to understand things. So you'll put your best developers into accounting, must be. And you will put all the developers are best, right? But you will say that, okay, I will put the second level of developers in billing, right? So here also what you can do is that you can, depending on the complexity, of the project, you can align your team accordingly. So now, because of this team autonomy, right, and individual development, individual deployment, right, now you have superb tech benefits, right? Now, what is the biggest technical benefit, right? The biggest technical benefit is that now what you can do is that you can go ahead and you can deploy individually, right? Individual deployment and individual scalability, right? So let me talk about it. So the biggest technical benefit you get now from this is individual deployment. So you can go ahead and you can deploy them individually. One does not affect another, and so on. You can upgrade and downgrade individually, and so on, right? Another one is individual scalability. So for example, now last some minutes back, I discussed about the hospital system. So in case of an hospital system, the billing. Now the billing will be used by how many people? 4 people who sits in the billing, 5 people, 1 accountant, let's say 10 people, right? So what you would do is that you would put some low compute resources, or you will put some low-ended machines over here, low-ended servers out here. Why? Because only 4 or 5 people are logging in, right? But now the appointment system, right, which is online out there, many people would be logging in. So there you would like to use cloud. So this is what is termed as individual scalability, and this on a long run definitely saves a lot of money, right? So this is again a big benefit out here. So I feel that I will use microservices. First thing, the decision has to come from management. See, here, the management should be willing to invest also. Microservices are costly. Microservices, because you are going to have queues in between. Even though we say individual development, individual deployment, still, the communication should be very tight, or else, it can lead to problems, right? So first one is from the organization side, the drive should come in from the management side. The drive should come in that we want team autonomy, right? And then definitely the byproduct benefit. Technical is a byproduct benefit, right? The byproduct benefit is individual deployment and individual scalability, right? So from my perspective, right? Remember, I have already listed down many benefits just some minutes back, right? But there are 3 big benefits I can just put down here. Team autonomy, owns, builds, deploys separately. Individual deployment, right? And individual scalability, and definitely reusability and other things. CI/CD, because now you can go and you can configure CI/CD for each service separately. That is again coming as a byproduct out there. So let us get started first with the vocabulary of what exactly is a domain. Now let us start using the official vocabularies of microservices. If you see, from some time, from whenever we have started this lecture, I've been using the word specific business functionality, specific business functionality, specific business activity. Let us use the word domain. A domain in a microservice, this vocabulary domain in a microservice represents a specific business functionality. So for example, if you have hospital, then appointment system is one domain, clinical is another domain, you can have lab management is one more domain, pharmacy is a domain, right? So domain represents a specific business functionality. So henceforth, we will use the terminology domain. Now, when it comes to microservices designing approach, right, the most common way of doing designing is by using DDD, domain-driven development. Why domain-driven development? Because domain-driven development software design approach, it's a design approach. It starts from the domain. It starts from understanding the domain. It starts from the domain users, how they use that domain. So DDD is nothing but it is a software design approach which actually starts the understanding from the domain, and from domain the architecture is decided, and from architecture the code is decided. So right from the design till the code, it starts from the domain. So DDD is nothing but wherein we start designing our architecture, our code, our project structure from the domain perspective. Now, many developers will say, sir, we have been doing object-oriented programming. This looks very similar. Actually, object-oriented programming comes at a very lower level. So for example, let us say that you have an hospital domain, and in that you have clinical domain example. Now in the clinical domain, the patient is the object, right? The patient problem is the object. The diagnosis is the object, right? But we are going little bit up, little bit 30,000, or you can say 50,000 feet level. We are starting from the business functionality. So don't think domain as objects. And please write down below, what do you think? Is domain an object? Because many developer thinks that domain actually is nothing but it is an entity, right? But I feel that domain is a problem space, right? It is a business functionality. What do you think? Is domain like object-oriented programming, or how it is? So now let us go ahead and try to understand that from the domain till writing the code, right? What is the approach of DDD? So you can see on my screen now, you can see here is our domain. So let us assume that we are talking about a hospital management system, right? HIMS out here. And from this, so this is your domain, and from there, you want to go ahead and generate the code, right? And we are saying that we will be using the DDD approach, right? Domain driven design. That is the approach we want to use, right? Now this DDD design, right, or the DDD approach is divided into two phases. So the journey from the domain till the code, we can divide that into two phases. So you can see I'm putting up a red line out here, right? The first phase is termed as the strategic DDD. Sorry for the spelling mistake if I'm making anything out here, right? The strategic design. And the second phase here is termed as the tactical design. Is termed as the tactical design. Now, before we move ahead into this strategical DDD and tactical DDD, right, let us try to understand the English meaning of strategic and tactical, because a lot of times you will see that developers use this word saying that this is a strategic thinking. We need a strategic thinking. We need a tactical approach, right? So many of the developers just use interchangeably, specifically, people like me, whose English is the second language. I used to use these two words very much interchangeably some years back, right? But strategy means that it is the bigger goals what you want to achieve. It is the overall approach what you want to achieve, what you want to do, right? So let us say that your bigger goal is that you want to become rich. I'm just giving an example, very bad example it is, right? So that is a bigger goal, right? Now for that, what are the smaller actions you will take? So that is termed as tactical. So you will say, okay, I want to become rich. So for that, what is the first thing I will do? The first thing is that I will do is that I will work hard, right? Must be, right? I would get some knowledge, right? So that becomes tactical. So whenever you are talking about strategy, this word, it means the bigger picture. It is the what and why you can think about. And when you talk about tactical, it is how will we do it, right? So in DDD, when you are talking about the strategic design, right, it is the overall structure, how it looks like. What are the different domains in that? What are the core domains? What are the supporting domains? How will you define your bounded context, right? How is your ubiquitous language flowing around? Then how is the context map taking place, and so on. So that becomes your strategical DDD. And then when you talk about the tactical part is where you start identifying your classes, your entities, your value objects, your service objects, your repository, your aggregate root, and so on, right? So those actually go at the code level, right? So whenever you are going from that thing, from that domain till the code, right, you will flow through a strategical DDD phase and you will flow through a tactical DDD phase. This is your domain, let's say HIMS, hospital management system, right? So now in the strategic DDD, right, the first step is, right, what you will do is that you will go and you will identify your subdomains. So let me just use this black color out here, right? So you will go ahead and you will identify your subdomains. For example, in HIMS, one of the subdomains, can be appointment, right? So I will just put here subdomain. One of them can be appointment registration, right? Okay. Another subdomain which can be here is the clinical. So this is again another subdomain here called as clinical, right? So one is you have a domain, another one you have a subdomain. Once you have created your subdomains, right, the next thing is that you have to take these subdomains and you have to put them into three categories. The first one is termed as the core domain. The second one is termed as a supporting domain. And the last one is termed as a generic domain. So what exactly is a core domain? A core domain is your bread and butter. So when you go to a customer, right, and you show your software, then the customer will differentiate you that how this subdomain is, right? So in other words, it is your bread and butter, it is the main part of your application, it is the heart of your application, it is that part of your application which differentiates that your software, how good it is from the other software. So that is the core domain. The second one is the supporting domain. Supporting domain helps the core domain to create the functionality or to make the whole software, right? So for example, if you say my core domain is, let us say, clinical, right? Let us say if it is a hospital management system, then clinical would be your clinical means where you record the patient name, where you record the patient records, you record the patient problem. So that is the heart of the hospital, right? Heart of a hospital system. So that becomes a core domain. Now for that core domain to function, you need billing, you need accounting, you need pharmacy. So those become the supporting domain. And the last one are generic domains. These generic domains are actually cross-cutting. They are general purpose. For example, security, logging, right, validation. So these are domains which can be used across all the other subdomains. So for example, you can see here, let us go back to the screen. So here you can see that we have this HIMS, right? And we said that we have an appointment and registration. This is one subdomain. Another subdomain is clinical. And one more subdomain I can create here must be of accounting, right? Another subdomain can be of security, right? So of security, sorry for this one, right? Now the next thing what you need to do is that you need to go ahead and say that, okay, each one of these subdomains, the classification. So you will say, okay, the heart of an hospital system is clinical. So now this becomes the core domain, right? The accounting, it is important, why not, right? But that becomes the supporting domain. This also registration becomes the supporting domain. And this becomes a generic domain. Security, logging will become the generic domain, right? So the first step is that you will go ahead and you will define your subdomains, and then you will put those subdomains into three categories: core domain, supporting domain, and generic domain. Now you would say that, okay, why do we have to give this classification? See, by giving this classification, you come to know that which one of your domains are very important, which one of your domains are cross-cutting, which one of your domains are supporting, right? And you can make some very critical decisions because of this, right? For example, now when you know that this is your core domain, you'd put your best developers on that domain. You'd make the best architecture for that domain. You'd put your best UI UX team on that domain, right? For example, in case of a hospital system, you would like to say, okay, it is clinical, so let us try to make it best. Let us try to put voice to text for doctors, not just notes. So you will try to make it best, so that you can beat the competitor in the market, right? So first one is you will put your best resources and developers on the core domain. The second one is you can also think about build versus buy. For example, when you look at a generic domain, right, and you say, oh, this is security, how would I go and take an identity server, or how would I use Azure Active Directory, right? Why should I build it in-house? So you can make decisions of build versus buy as well, right? And the third important point also, which I feel, is scalability. For example, when you are saying that, okay, this is, let us say, a clinical domain, right? And the clinical domain, you will say how many guys will use it, how many doctors will use it, 4 or 5 at a given instance. So you would like to put some low-ended server, or you would like to put the hardware resources, you will put little bit which is of medium size, right? But then you will say, oh, appointment and scheduling, which happens online. People go and do booking appointment through phone, they do it through online, they do it through app, right? That is where you would like to put your higher end servers, right? So even the scalability, independent scalability also you can bring into picture, right? So once you know that what kind of domain you are dealing with, right, you can organize your resources, you can decide the build versus buy, you can decide your scalability and so on. The other vocabulary which is very important, or I'll say the concept which is very important in microservices as well as in DDD, is bounded context, right? Now listen very carefully, right? I don't know the example which I'm giving here, will it resonate with you or not, right? Let us see. So now let's take again the example of our HIMS, the hospital management system. So now we say, okay, we have defined our domains, our subdomains, right? And the domain expert is sitting and talking with the developers. So let us say that you have development team, who is going to go and develop appointment. You have another development team which is going to go and develop clinical for doctors and nurses. You have another development team which is sitting to do the pharmacy. You have another development team which is sitting to do the labs and blood test and X-ray scans and so on, right? So all these 4 subdomain people are sitting and the domain expert is talking. So let us say he makes a statement number 1, right? So in statement number 1, he says that the patient, whenever he books an appointment, he shouldn't book an appointment for the prior time and the prior date. Means, let's say if it is 4 p.m. now, he cannot go and make an appointment for 3 p.m. Statement number 1. Statement number 2, he says also that a patient, whenever the patient is attended by a doctor, the doctor should put the notes and he should also put, what kind of medication he has to take, right? The third point he says is that whatever medication the doctor has given, only those medication the pharmacy person should provide. So when he goes to the pharmacy, only those medicines, should be provided. And he also makes another 4th statement where he says that whenever you publish a lab report or whenever you publish a scan report, right, it has to be signed by 2 doctors. Now look at all the 4 statements. I'm flashing all the 4 statements on your screen. Now what happens out here is anyone who is sitting out over there, he would think that, okay, everything is related to patient. The appointment is related to patient. The notes is related to patient. The signature which we required is related to patient, right? So everything is patient and patient, right? But actually, the context is different. The first statement, what I said out there, right, is related to the appointment subdomain. So when the appointment is happening, the timing, the date, which doctor to meet, right? It is related to the appointment team. So the appointment developers who are sitting, for them, this is very important. The second one, where I said that, okay, the doctor has to put down the notes, the doctor has to put down the medication, is related again to the patient, but the context is clinical. The third one, the context is pharmacy. So when he goes to the pharmacy, when he goes to the dispensary, right, he says, okay, like he comes in and he says, okay, like doctor has prescribed me all this. He goes and checks and he says, okay, this is what I'll be giving you. The fourth one is related to the labs. So when he actually goes and does the blood test, at that time we are talking about 2 signatures. So what I'm trying to say is that, listen to this statement very carefully. Everything is the patient model, what we are discussing. The domain experts and the developers, they are discussing about the patient, but the context is different. This is termed as a bounded context. A bounded context is nothing but it is a logical boundary. It is a logical boundary, inside a subdomain or around the subdomain, wherein the domain expert and the developers, they talk in a consistent vocabulary, they talk in a consistent way, they talk with consistent rules, right? And when you're talking with that consistent vocabulary, when you're talking with that consistent rule inside a bounded context, right? That rules, those vocabularies. So when I say, okay, patient is about appointment time, I'm talking with the appointment domain. When I'm saying patient is all about, pharmacy, or I'm saying the patient is all about the bills of the pharmacy, I'm talking with the pharmacy person, right? This is termed as the bounded context. I repeat this. This is termed as a bounded context. A bounded context is a logical boundary around a subdomain wherein you have consistent models, wherein you have consistent vocabulary, wherein you have a consistent language, and that language is termed as ubiquitous language. Ubiquitous language, I'm writing down all on the screen out there. So now let me go to the screen out here and let us try to draw a visual diagram of where exactly does the bounded context and the ubiquitous language lies. See, what happens is that, one is that I'm speaking out here, but another is that if you see an image, if you see a figure out there, it will make things clear, right? So let us continue again with our image out there. So you can see here, remember, this was our strategic DDD, this was our tactical design, right? And we were saying that from domain, we want to go till the code, right? So the first thing is we had a domain, then we had a subdomain, right? Now this is the appointment subdomain, this is the clinical subdomain, this is the accounting subdomain, and so on, right? So now what happens here is inside the subdomain, you will have a bounded context. I'm just drawing it. So this bounded context is now related only till appointment, right? And inside this, when we are discussing the patient model, I'm just writing, this is the model, patient model. We'll be probably discussing about, doctor slots, the doctor slots are free or not, right? So this, whatever models we are discussing around this, right? they all are having consistent vocabulary. They are having consistency in terms of rules. That is having a consistent language. So this consistent language, I'll just create this arrow like this, right? So there is a consistent language. So when the domain user says that appointment, it means he's talking about the appointment subdomain, right? This is termed as the ubiquitous language, right? Now look at this. This is a clinical subdomain, right? So inside the clinical subdomain also there is a logical grouping of, so these are all bounded context. Please remember this is a bounded context. Bounded context. This is another bounded. This is the appointment bounded context. This is the clinical bounded context. Sorry for my handwriting. So here also we have the patient model. So we have patient model, we have medication, what the patient has to give, we have notes, right? Now see, here also there is patient, here also there is patient, but there is a big difference. Here this patient is all about appointment, appointment date, appointment time, appointment with which doctor, right? While this patient is all about treatments, medication, the patient problem, the patient history, right? What kind of treatments we are giving to them. So both of them are patient, but the ubiquitous language, the language what we speak of a patient inside the clinical is very different about the patient when we takes the appointment, right? So domain, subdomain, inside the subdomain you will have a bounded context. Now please remember, you can have multiple bounded contexts if you want. Inside a subdomain you can have a multiple bounded context. In my lifetime I have seen it very rarely, but it is possible that you can have multiple bounded contexts. For example, in clinical I can say, okay, there is a bounded context for doctors when they do clinical, and there's a bounded context for nurses when they do clinical. For example, nurses actually take the weight and height and the lot of other things which the nurses do, which the doctors will not do, right? So you can have multiple bounded contexts if you want, right? But mostly I've seen that there's only one bounded context, right? So domain, subdomain, bounded context. Inside the bounded context there is a consistent vocabulary, there is a consistent model thinking, the domain person and the developers are on the same page, and there is a consistent ubiquitous language. So now before we go towards the next video, the next chapter I will say rather, which is about the context map patterns, right? Before I discuss about those 9 patterns, I want to talk about QuestPond, right? What is QuestPond? QuestPond is a training portal specifically for Microsoft technologies. If you're a C# developer, if you're a .NET developer who is working with SQL Server, with Azure, right, with cloud, right, with Angular, with React, right, ASP.NET MVC, microservices, right, then this website is for you, right? So in this website, what happens is that we have, like, if you're looking for a job, let us say you're saying that I want to get prepared for interviews, then we have the ASP.NET interview questions, we have the architecture interview questions. You can see on the screen I have logged in currently by a QuestPond member, right? JavaScript interview questions and so on, right? Now you will say, no, like one is the interview questions, but second I want to also do hands-on. So what you can do is that, like, this is Angular interview questions and you have Angular step-by-step, right? For example, this is the ASP.NET interview questions, right? Then you will also have ASP.NET training. Also on the top of it, we have live training also. For example, this is a microservices video, right? We are having a live training in the coming 2 weeks of microservices, right? So you can see these red things out here are the live trainings, right? You can also attend that. So for example, I'll just tell you, like, last time we had the Azure crash course training. In 8 hours we did Azure, right? Then we had the React.js by Pradeep sir. We had the Angular training also by Pradeep sir, right? And you can see last year I also took microservices training, and this time I'm repeating microservices training for the new subscribers, right? So what you can do is that you can go to questpond.com and you can chat on questpond.com, right, and talk with one of our support people, right, and they will help you. So a very quick update on what exactly is QuestPond. So let us now move ahead with the next chapter, context map patterns. What are the different context map pattern and what exactly they are? So now that we have understood bounded context, we understand that it is a logical boundary inside which any stakeholder, either the developer, either the project manager, either the end user, either the domain user, either the tester, whoever is working in that bounded context has the same thinking, they wear the same hat, they understand that this model of patient here is a billing context, this model of patient here is an accounting context, right? In other words, they follow the same ubiquitous language, right? And also the development team, they also work focused on it. The stakeholders work focused on that bounded context. They worked isolatedly on that bounded context. But when we go back to the real world, right, definitely you cannot have isolated bounded context. These bounded contexts have to collaborate with each other. The team members have to communicate with each other. They have to interact with each other. They have to relate with each other, right? Without that, the whole system cannot be completed, right? And that's where exactly we are talking about context map. So context map defines how two bounded contexts will collaborate with each other, how they will communicate with each other, how they will interact with each other, how they will talk with each other, and so on, right? Now, if you look at this definition of context map, which I'm flashing on the screen, I want everyone to read that definition. In that definition, I have not said the word integrate, publisher, subscriber, right? I have rather used the word more generically, saying collaborate, communicate, interact, right? In other words, what I want is that I don't want that you as a developer should start jumping the gun saying that, oh, context map means that we have to put an API in between. Oh, context map means we have to put a Kafka queue, right? Or some queues or some tables out there. Don't think about technical at this moment. We are still walking through the strategic planning, right? Remember that diagram which I flashed sometimes back? There is strategy and there is tactical. So we are still at the strategy level, right? So don't jump on the gun saying that, okay, that think technology. For technology, when we start with tactical, we'll talk about it, right? So for better understanding, right, let me try to rephrase it, more from the people perspective, from the team perspective, right? Because when we say bounded context, they are nothing but, definitely they are logically self-contained units, right? But on that, actually people work, on that teams work, on that managers work, right? So let us try to redefine this definition, what we are seeing on the screen, more from the people perspective. So context map defines how team member working in one bounded context will interact with bounded context with other bounded context team members. Let me repeat this sentence again. So you have team members who is working in one bounded context, and there are team members who are working in other bounded contexts. So when you talk about context map, what we are defining is that how will they interact with each other? What is the protocol of interaction, right? What is the contract? What is the agreement on which they interact, right? Now, let me give you some example out here. For example, you will say that one bounded context team member have an upper hand. Other bounded context team members have a lower hand. In other words, the upper, let's say you have the core domain and the bounded context, which is a core domain, you will tell that team members, see, go ahead and dictate what data you want. You want to send in XML, you want to send in JSON. This other team member, who is there, who's working in other bounded context, has to accept as it is. Let me give you an example. So let us say that I have I'm going to create a billing software. So billing becomes the core domain. But when I make an entry into billing, it has to make an entry into accounting domain. So I'll say, okay, billing is my core domain. So let the billing team members define how they want to work, right? And the accounting team members have to adhere to it. So now if you see here, billing team is having an upper hand and the accounting team is having a lower hand, right? In terms of, because one is a core domain and other becomes an ancillary domain. So now the accounting team will say, see, I'm sending data in XML example, and I'm sending the date and time as GMT. Now the accounting team does not have a say on this. They will say, okay, send us whatever it is, right? We will parse the XML. If you're sending GMT, if you want to convert it into local time, we will do it, right? This is termed as the context map pattern. So there are 9 context map pattern. The one which I've discussed at this moment, where we are saying that one team has an upper hand, whatever he sends, right, the other team has to accept it, is termed as a conformist context map pattern. We have 9 patterns like this, right? We'll discuss that. But before we go and discuss those 9 patterns, right, let us talk about 2 vocabularies out here: upstream and downstream. So upstream bounded context means the bounded context which publishes data, or we can say which produces data, while downstream bounded context means which consumes or depends on that data. Now I'm flashing both the definitions out there. My only suggestion is that don't focus on that publish and consume. You know why? Because the time you focus on the publish and consume, in your mind it will become API. You know, it is not an API. Please understand, it's not an API. So must be you can focus on the word produce. You know, produces, I will not even say produces data. Sometimes they can produce events as well, right? So produces things, and the downstream bounded context consumes things, right? Or depends on it, right? So upstream bounded context, when we say, right, they are those bounded contexts which actually sends, you know, things to the downstream bounded context, right? So if I'm using this word out here, then you should think about that downstream is the consumer, is he depends on that, right? And when I say upstream, means that bounded context is the generator of the data, or it is the producer of the data. So let us start with all the 9 context map patterns out there, right, which helps you to define how the communication works, how the protocol works, right? So let me start with the most easiest one, right? The one probably you will find it everywhere. Big ball of mud. Nothing is clear out here, right? The first one, the big ball of mud. Big ball of mud means that nothing is clear. You know, one bounded context code is used in other bounded context code, right? This both of them are entangled. Nothing is clear. There is no boundaries. There is no ownership, right? Everybody is just working on each other. I mean, like, you have started with microservices, right? But you are working like a monolith, and this happens a lot of times. People start with the vision of microservices, right, and they end up as a monolith, right? So big ball of mud. Why I have put this this context pattern out here is that if you see that no ownership is clear, right, that means that you have already started with big ball of mud. In other words, if you have not decided how the context map is, right, that means by default it is big ball of mud. The next context map pattern is shared kernel. Shared kernel means 2 teams share a part of the domain model. For example, let us say you are saying billing and invoicing. Example I'm saying, right? So billing and invoicing, they both of them share a customer model, right? So for that customer model, some part of the billing is needed and some part of inventory is also needed, right? So what the both of the team will do is that both of the team will say, okay, let us create a customer model which will be shared between both of us, but we will work independently. But for when it comes to sharing the customer model, both of us will use this customer model, but the rest of the part will be working independently. Shared kernel, a part of the domain model is shared between the team members. The other context map pattern which is seen in many places is the conformist one. The conformist context map pattern we just discussed, right? Here what happens is one team must use the other's model as it is without any influence or without anything. You know, as we said that you have one team out here which is let us say the billing, and one team is accounting. The billing team says that, see, this is what the data I'm sending to you. Now you like it, you don't like it, right? That's it. You cannot tell me that you have to do this and you have to do that, right? Definitely the necessary data and the necessary things has been provided, but you cannot dictate the billing team, because the billing team is probably it is an important team. Probably that is our core model, right? That's our core domain. So the accounting team actually becomes a little bit short before them, right? And they have to say, okay, you give whatever data it is, we'll just confirm, as per it, right? But if there are any issues, you have to help us out, or else we'll just use it as it is. Conformist, one team must use others model as it is without any influence. In case of conformist, there is like one team is like a dictator. He will dictate it. Conformist. The other context map pattern, which is more lenient or it is more democratic as compared to conformist, is the customer supplier. Now, before I start with customer supplier, don't think about customer supplier means the supplier who supplies the product, and that, or customer who buys the product. It's not in that terms. Here, the customer supplier is meant, from the upstream and downstream perspective. So one team, the supplier or the upstream, serves the other team, which is the customer, which is the downstream. Remember, upstream and downstream, with negotiated needs. Means there is a negotiation. So here the supplier says, okay, here is an API. Now I don't want to use the word API, but let us use it. Here is the API. Here is the data I'm providing, right? Then the customer who is consuming says that, okay, this is good, right? Can you do some modification out there because we need it, right? So here there is some negotiation allowed. customer, supplier. I feel that this is one of the most used context map pattern. I've found it everywhere. The other context map pattern which I find very useful is the anti-corruption layer. These words, I mean, are like so glamorous. I don't know what word to use there, right? Anti-corruption layer. Anti-corruption layer. Anti-corruption layer is nothing but a team builds a translation layer to isolate from other teams' model. So for example, now from the upstream, you are getting some models down below, right? You're getting a model and then you say, oh, these 3 fields I don't want. I don't want to use these words fields, right? But for now, okay. So these 3 things I don't want, this thing I don't want. I want that this model should be split. So what you do is that you create a translation layer, a conversion layer in between, which will translate that model to another kind of a model which your business context, or I'll say, sorry, your bounded context understands very well. Anti-corruption layer. A team builds a translation layer to isolate from other teams' model. Open host service. This is again one more context map pattern out there. Here what happens is a team publishes a service, right? It publishes a service and that anyone can use it. Right? For example, somebody has published a REST API where you can go and you can know that what is the climate and weather of a particular location. Now that is an open host service, right? In case of an open host service, there is always some standards like REST, or they are using HTTP like post, get, put, delete. They are using some JSON format, right? So open host service is mostly, where you want to go and publish a service, right? And others can just use it freely, but it will have some standards, which has been agreed in the IT industry for data communication or for cross exchanges of data. Published language. Published language is nothing but where the team agrees on a shared language, or I can say on a shared vocabulary, or a shared language format to communicate between each other. Now don't start getting into, again I am repeating, don't start getting into, looks like JSON. No. Published language does not mean JSON, right? It is the vocabulary. So if you are saying, for example, let us say there is accounting and there is inventory. Now both of them need customer model, right? So what is the shared language you both want to say about this customer? Do you want to say it customer accounting inventory, right? Cust accounting inventory. So again, it is about vocabulary. It is again about how, the ubiquitous language, right? You don't want any ambiguity, right? So published language, the team agrees on a shared language. Again, don't think about JSON and XML. A shared language or a shared vocabulary format to communicate with each other. Partnership. Partnership means that 2 teams collaboratively, closely, by influencing each other, by working tightly with each other, they work equally on some common thing, right? Partnership. So for example, let us say you are saying that you have a billing and you have accounting, right? Now you would say that, okay, from billing to accounting, we want to post data, right? But then how will the mapping work? So you need to probably, both of you guys have to work on a shared code out here. Now I know that you must be thinking shared kernel. I'll come to that, right? I'll come to that. So you will work on some shared code out here saying that, okay, how will the debit and credit be split, right? So both of you guys will work on this common code base, right? Both of you will collaborate, influence also each other. You will discuss with each other saying that, no, I'm sending one amount 100. You tell me how it will split into debit and credit. He will say, see, from accounting principle, it is like this. You will say from billing principles, it is like this. So this is more of really a shared code. If you remember about shared kernel, it was a shared model. It was a shared model. In case of partnership, you are actually working more tightly. In case of a shared kernel, what happens is there is one model which is shared, and then again both of you guys work parallelly, right? Or both of you guys work independently. Separate ways, the most easiest one. Separate ways means team works independently. There is no integration needed. There is no collaboration needed. Now, why have they kept it? Why have they kept this pattern out here, right? For example, the big ball of mud, I have said it explicitly, and separate ways also I'm saying explicitly, because sometimes you will decide on the strategic level that both of the teams are independent. We shouldn't be talking with each other. Separate ways, right? Now, before we move towards chapter 15, right? I'm just flashing all the 9 context map patterns we have discussed till now. See on the screen all the context map patterns. Have a look at it. If you wish, you can also pause this video and go through it, right? And by looking at all these context map pattern, I want to ask you guys, I told that, that the context map pattern actually does not dictate anything technically as such. But there are some patterns in these 9 patterns which actually pinpoints technically, I will not say directly, but mildly. So write down below that which of these context map pattern, when you read it, right, you think that, oh, this context map pattern, I feel that it implies this technology, right? So let us see that how many of you guys put down in the comment that which of these patterns implies technology. Now, there are some very important points I'm to share about this context map pattern. You saw that we discussed almost like 9 patterns out here, but take it as a pinch of a salt. Do not follow it like, how do you say, an absolute truth, like a gospel, like the ultimate light, right? Like an ultimate commandment. So don't follow it like that. Take it as a pinch of a salt. Think naturally. This is very important, right? For example, don't think that, okay, like I'll just use only one context map pattern. That is not possible. Must be we'll have a mix and a match of it, right? For example, it is very much possible that you are using an open host service, and then at the downstream, that means where you're consuming that open host service, you have actually put an anti-corruption layer for translation. You can have 4 or 5 context map pattern you will see getting mixed up or getting aligned together, to do your work, right? So very much possible, right? So don't take it that I will take only one pattern, I will follow only like this, that does not work out here, right? And second, always remember that these are guidelines. See here, what the whole thing, DDD is trying to say is that basically understand the implication of how much the communication will happen between both the team members. Means, for example, when you say shared kernel, means there is a model, both of them only work on the model and then they work parallelly, right? But when you talk about customer supplier, right, over there, each one of them are influencing each other. Now the communication has increased. If the communication has increased, you need to be aware of it. That's what it says, right? So, whenever you are looking at this whole patterns out here, right, just make sure that these are guidelines. This will help you to understand that how loosely coupled are your team members or how tightly coupled are your team members. Now, I would like to go ahead and talk about few things out here, and I want everyone to start putting their thinking hat, right? Because whenever I look into these patterns, right, I find that there is so common boundary in between them, right? Sometimes they look very same, right? So let me start with some of them, right? For example, open host service, right? What do you think? Open host service, we said that open host service is nothing but a team publishes a service, right? And other teams can use freely, right? That's what we said is open host service, right? Open host service versus conformist. See, in case of conformist also, what happens is you are publishing the things out there, you are sending the data out there, other person has to consume, right? Think about it. What do you think? Conformist versus open host. What is that difference, right? I can just give you the difference out here, right? Conformist is more, I'll just put some few words. I want you guys to go and read about it, right? And if you're knowing the answer, right, please participate, right? Please participate on the screen. I'm putting that how you can participate, right, with the answers. So think about it. So when you say open host service, that means standards. I'm putting some words out there. That means third party, right? When I'm talking about conformist, means legacy, no standards, compulsion, right? So there are some few words I put out here. So go ahead and think about it. What do you think? What is the difference between open host service versus conformist? Another thing, another pattern, which confuses me is that, and many people, which confuses them is that when we talked about the shared kernel, things are shared. Also, we talked about partnership, where the two teams will work closely on something. What is the difference? Already I've answered it, guys, right? I just want you to think. Why I'm telling you to think is that, sometimes, these patterns you will find very, very thin line in between them, right? But you will find the difference, right? And as I've already said that don't go into thinking too much, right? Don't go into thinking too much. What you have to do is that you have to just understand, okay, this is the overall thinking, right? And where does my team stand? How does my collaboration of my project stands? What should I choose and how I should customize, for my project? That's what you should think. But for these two, what do you think? What are the differences between two of them? Please put down below. Let me know what is going in your mind. So now that we have covered so many topics out here, and almost the context map is the last thing in the strategic DDD, right? Let us now go ahead and complete the whole visual diagram which we have been discussing when we started this class, right? So here it is. I'm going back to my screen. So remember, at the top you have the domain, right? HIMS. Then what we do, we go ahead and we divide our project into subdomain, right? And then inside every subdomain, there is a bounded context. So there can be one bounded context or there can be many bounded contexts. And inside the bounded context, what do we have? Inside the bounded context, we have our model. Now I'm not writing the full form. I'll be giving a final image later on. So we have the model, we have the ubiquitous language, we use the same sentence, we use the same words, right? We talk with the same tone, the same context, right? So this whole thing is a bounded context. Bounded context, right? In the same way, here also we can have a bounded context with again the models, with the ubiquitous language, with the same context thinking, right? And so on. So again, this is a bounded context, right? Now, between the bounded context, we said that context map actually it defines the way they will talk with each other, the way they will communicate with each other, right? So between this, both of them, we have our context map. My diagram is horrible, but I hope that I'm making sense. Context map. And we talked about different context map patterns, like conformist, and customer, supplier, and so on, right? So depending on that, you will define the context map, right? So till here, whatever you have seen now is the strategic DDD. It is the strategic DDD, right? Now when you are done till here, then comes the tactical part. So from here now, we can now go and start writing the code, which is the tactical part, right? So this was the final revision of the strategic DDD. Domain, part 1, your domain, your requirement, the whole system. Subdomain, you go and you define your subdomain into core domain, into ancillary domain, right, and so on, into generic domain, right? After that, you say every domain we will have to speak the same thing. We will have to speak the same words, same sentences, ubiquitous language. We'll have the model, right, where everybody will think in the same way, the bounded context. And then between the bounded context, you use the context map. This diagram is very important. Try to, take a snapshot and put this diagram on your head and on your heart, I will say, not on the head, but on your heart. So now that brings us to the end of this session, right? And let us talk about what is for the next lesson I want to take in microservices. So till this 1 hour, everything was strategic. Everything was planning, right? So that's why we did not have any code, but I hope that you have understood all the different terminologies, right? So now let us go to the screen and let us talk about what I'll be doing in the next video, right? So here it is. So what we have done till here, right? All these things. So domain is there, subdomain is there. Inside the subdomain, there is bounded context, and then bounded context has models, it has context, it has ubiquitous language, it has context map. We talked about those 9 context map pattern, right? Now is the time to jump towards coding, right? And that's what exactly I'll be doing on my lab 2, on my lesson 2, I will say rather. So in lesson 2, we will start coding, right? But before coding, right? So now that we know the requirement, this is strategic. Now over here, what will happen? We'll say, okay, we want to create a different classes, right? Okay, so now depending on the requirement, we'll say, okay, we'll get some classes which are entity classes, which are service classes, which can be value objects, right? Now you will say, oh, entity classes. So for entity classes, we will need an aggregate root, right? We have to create a class for aggregate root, must be, right? In services, we will have a repository class. Remember, at the end of the day, microservices, when you start coding, right, it will start spanning across patterns also. Huh? So we'll need the repository pattern. And when we are talking about repository pattern, these entities have to be coded in a CQRS style. So from here, our coding will start, right? So the lesson 2 will be on classes, different classes, entities, services, value objects, aggregate root, repository, CQRS, and so on, right? And remember what I've said, if you give me 2000 likes, I will release this second video, or else this second video only goes internally, second, third video, everything is going internally for our subscribers. Please go to questpoint.com and you can subscribe out there. But if you make that happen, that 2000 likes, I would like to also give it on YouTube. So that brings us to the end of this video. I hope that you enjoyed all those 17 chapters, whatever I've discussed, right? And I hope that this video was useful, right? And also, so remember, if you go and if you share this video, you get this architecture interview question PDF. If you go and hit that 2000 likes, you get the next video also. I will put it right on the YouTube channel. And don't forget that we are having the microservices training on QuestPond. We are having the Azure training on QuestPond, recorded videos on QuestPond, right? Go ahead, visit questpoint.com, chat with our team, our support people out there, and see that if that website is useful, right? So thank you very much. Happy learning, happy job hunting. Hope that I see you in lesson 2 of microservices.